let's start consider what is mean principle 14. But before it, let's do some experiment. Again, I'll show for you several examples, and after this we'll ask you what was similar, what was totally different. Okay? Example number 1. I need measure time, and for measure time I can use the receiver. This receiver can measure 8 minutes, okay, but you know there is alternative way for measure time, and I can use alternative technologies for measure time. It is timer, 8 minutes, okay, 8 minutes, okay, 8 minutes, and I can measure 8 minutes.
시간을 재는 경우에도 첫 번째 시간이라는 방법은 모래시계를 이용해서 될 수 있고요. 두 번째 뭐죠? 타이머 이용해서 시간 재는 게 첫 번째입니다. 첫 번째, 두 번째, 두 번째 이렇게 쭉 봐보세요. 어떤 연관성이 있는지.
It will be example 1. Let's consider example 2. We have summer season, hot weather, and we think about decreasing temperature of face. But there is alternative technologies for decrease temperature of my face, and we can use this technology. Okay, why not? Okay. Oh, more efficiency.
그래서 날씨가 더울 때
bigger productivity.
온도를 떨어뜨리기 위해서 쓰는 것으로 첫 번째는 부채고요. 두 번째는 선풍기래요. 저 두 번째입니다.
We can begin think about solve the problem for hold picture in the wall. Yeah? We have some picture and we think necessary hold this picture in the wall. And for solving this problem, we can use nail and hammer. Yeah? Nail, hammer. Okay, and we can solve this problem. But you know there is alternative technologies for solving this problem, and I can use not hammer, I can use screwdriver. Screwdriver. Okay. And solve this problem again. Why not?
세 번째는 엑셀을 걸기 위해서 못을 박을 수도 있고요. 또는 스크루드라이버에서 나사못을 박을 수도 있네요. 세 번째입니다. 목과 나사하고.
And it will be example number 3. Example number 4, we can consider toy for children. Main target of this toy move in space. But you know different toy for children, and we can use different design toy for children. We can use this system here. You know what is it? Boomerang. I can move it, boomerang, and remove here, return here. Or I can use this toy for children, similar function, move in the space. No problem, move in the space. It will be example number 4.
네 번째 장난감이죠. 그렇죠. 다 움직이는 장난감이에요. 첫 번째 장난감 뭐죠? 공이죠, 그냥.
Example number 5.
두 번째는 뭐였나요? 부메랑이나 또는 이렇게 하늘로 날아가는 거. 그렇죠. 그게 네 번째예요.
I need measure length for some curved line. I have some curved line, and I have equipment for measure lengths. You know this equipment. Necessary to do segmentation. After this, I'll do measuring. 1, 2, 3, 4, 5, and calculate, and I'll take, for example, 77 centimeters. But there it is long way, small efficiency, and I have alternative technologies for measure length. You see device. This device has revolving wheel and revolving pointer. And I can insert it in 0, and after this I can measure. Oh, 77 centimeters. Okay, it will be example number 5. My question to you, what was similar from my examples?
네, 마지막에는 뭐죠? 곡선의 길이를 잴 때 자르려면 뭐 해야 될까요? 여러 개를 쪼개서 재서 둬야 되겠죠, 그렇죠? 하지만 한 번에 곡선을 잴 수 있는 저렇게 TV 회전하는 그런 도구가 있죠. 그래서 한 번에 잴 수가 있는 거예요. 그게 마지막 예예요. 다 공통점이 있죠, 그렇죠? 앞에 거, 뒤에 거, 앞에 거, 뒤에 거 패턴이 보이시죠? 공통점이 뭐예요?
직선이 곡선은.
네, yeah, just straight and rotation.
Absolutely. And I heard your voice. Yes.
Everybody said. Right?
Everybody. No problem. Everybody, I hate it. It is seldom case when everybody students see correct answer. Yeah? Same here. Okay. Really, you right now you discover principle 14 looks like as Mr. Altschuler, and really according to our knowledge from mechanics, there is obligatory two kind of movement for every technologies: forward movement and revolving movement. And if you know these rules, you can immediately calculate new kind of technical systems with new kind of movements, because it is a rule from mechanics. And by the way, huge amount of principles from 40 principles repeat our knowledge from physics. Several times I define our discipline as a special chapter from physics for inventor. And really, if you know, every technical system must have forward movement, must have revolving movement. Knife have forward movement, but I immediately begin calculate version knife with revolving movement. And it can be, for example, knife for pizza. Yeah? Revolving movement.
직선운동이랑 회전운동 항상 생각해 보시면 돼요.
But we begin talk about important trend with name conductivity.
여러분들 이거는 전도성의 트렌드, 여기 보시면 전도성의 트렌드 중에 하나의 패턴입니다. 동작의 형태를 바꿔보세요. 하나의 패턴이에요. 여러분들 뒤에 전도성 트렌드 있잖아요. 거기에 전도성 트렌드 밑에 여러 개의 서브 트렌드가 있거든요. 그 중에 하나의 트렌드가 동작의 타입을 바꿔보는 거예요. 그거에 해당되는
Conductivity.
직선 운동이라면 회전 운동을 바꿔보세요.
Yeah, this trend has several sub-trends, and let me deliver for you this knowledge, because anyway, this knowledge correspond with some principles. And sub-trend number one, different category of movements. You can open your textbook in page 2. In page, I don't see number.
몇 페이지에? 201페이지. 201페이지 가보세요.
And you can see this diagram in this page. Really, if we can see the evolution of techniques, we can define 6 categories of movement. One category, first category movement, impulse movement. Next category movement, forward movement. Next category movement, forward movement 2 times in one side and in opposite side. 2 times.
펄스가 뭐냐면 맥박이죠, 그렇죠? 맥박이 뛰는 것이 맥동도라고 이렇게 짧은 게 턱턱턱 하는 거 있죠. 그게 펄스 무브먼트예요.
Next category movement,
포워드는 직선 운동이고요.
pendulum movement.
프릭션은 마찰 운동에서 톡지라는 것이 마찰
You
운동.
know what is meant pendulum, yeah? It is pendulum.
펜듈은 뭐죠? 시계 치니까 진자 운동이죠, 진자 운동. 진자 운동.
Next category, revolving movement.
네, 그다음 리볼빙 로테이션 회전 운동 보는 거.
And by the way, what is meant revolving movement? Pendulum movement, it is not full revolving. Revolving, it is full.
진자 운동은 회전 운동의 일부분만 움직이게 되는 거죠, 그 운동이죠.
And last category, wave movement. Okay,
마지막에 파동 운동.
we have in our classification system. In our classification system, 6 category, and we are 6 category. We can do description for every machine. It will be absolutely enough. It is full algebra about for description of different type of movement, especially if you will understand every category movement regarding to principle number 6. We can use together.
결국은 모든 움직임을 여기까지 줄로 다 들어갑니다. 물론 저걸 섞어 쓰기도 하고 회전하면서 직선 가기도 하고 그렇죠. 회전과 회전이 같이 붙어가지고 오실레이션이 되기도 하고. 근데 기본적인 패턴은 6가지 벗어날 수가 없어요. 저게 섞여서 쓰여지는데 결국은 6가지 중에 하나에다 들어가는 겁니다.
So, and according to this category of movement, you can calculate new version of ideas, new version of something. And if you meet in the market, for example, music instruments, these music instruments, you can immediately define. Oh, it is friction movement, right? Forward movement 2 times. But principle 14 recommend you, if you have forward friction movement, please think about revolving movement. Yeah?
악기 이렇게 이제 하는 거 어떻게 그런 뭘 생각해야 되는 거죠?
And here,
돌리는 걸 생각해야 되는데 돌리는 거를 회전을 연주하는 거.
you begin think how I can invent these music instruments again with revolving movement. It is obligatory possible because it is rules from nature. And let me illustrate it. It is similar principle of operation. Similar principle of operation. But for playing this instrument, necessary do revolving. Hold it and do revolving. Blow and do revolving. Unfortunately, I cannot play to this music instrument, but it is absolutely similar music from music artists. And you can continue a consideration every steps and think about different category of movements. Let me illustrate only several categories of movement. For example, what can be impulse movement? Impulse movement you can find in Spanish castañet. Yeah, you know. Spanish music instrument with using of impulse movement. Or by the way, drum. Impulse movement.
드럼 치는 것도 모르네. 펄스래요.
You can consider this instrument from Vietnam. I have been in Vietnam and bought it in Vietnam. We can create music. It is a wave movement. Let me say. In macro level, it is vibration. In micro level, it is vibration also, but it is vibration of fields. For example, what is meant light? I mentioned light. It is a combination from magnet and electrical field, and light, it is vibration of electrical and magnetic field together.
빛도 결국 파동이죠. 빛도 파동. 우리 파동이고 그렇죠? 다 파동이죠.
And according to this definition, you must understand. X-ray, it is wave movement.
X-ray 파동이죠.
UV, it is wave movement. Infrared, it is wave movement. Radio wave, it is wave movements also. By the way, internet, it is wave movement also. Use wave movement also because internet use electromagnetic waves. And it is contained by subtrend number 1. We call this subtrend different kind of movements, and this subtrend can for us help calculate new kind of solution. For example, you can think equipment for bodybuilding commonly use friction movement, yeah, for training of muscles. You can immediately think, can I calculate idea for new product for bodybuilding with using of revolving movement? Is it possible? Yes, it's possible also, because if you remember our previous example with gyroscope, we can use gyroscope, and gyroscope have gyroscopic force. If you do inclination axis of gyroscope will obligatory return in your old position. And it is big force. This force depends from speed of velocity. And
보통 일반적인 우리가 근력운동 어떻게 하나요? 이렇게 하나요? 네. 직선운동식이죠, 직선. 그렇죠.
Let me show for you some examples.
근데 저거는 뭐 하게 되니까 그냥 뭐죠? 회전운동을 이용해서 근력운동할 수도 있겠네. 그렇게 만든 도구입니다. 저기 안에 있는 게 팽이 같은 게 돌거든요. 아까 회전하면 무슨 힘 같은다 그랬어요? 자이로스코픽 이펙트 같다고 그랬죠. 기울면 한쪽으로 가려고 하는 것들. 손을 딱 잡게 되게 되면은 계속 안에서 움직여요, 이게. 손에 힘이 엄청 들어갑니다.
And this equipment use gyroscopic effect. And I have starting thread for increased velocity. Yellow balls, it is gyroscope. And I do starting. I increase velocity. Oh, I became few gyroscopic effect. Right now you will continue. Okay? Repeat my movement. Be careful. Feel? Did you feel? Feel gyroscope.
가만히 딱 있으면 돼요.
Continue. Not stop. Prohibit stop. And you see, we obtain new equipment for bodybuilding, and we continue. And right now you continue. Okay. Be careful. Continue. Not stop. Okay, later. During break you can continue it. During break, every student can try use this equipment and feel forces from gyroscopic effect. Okay, next subtrend, important subtrend for solving problem from conductivity. It is turn of axis. Frankly speaking, it is using of resources of space. What does mean turn of axis? If you consider this knife, you can define it is revolving movement, and during this revolving movement, location of axis horizontal, right?
단순하게 말씀드리는 게 뭐냐 하게 되면은 축이 바뀌는 거예요. 저 보세요. 회전축은 뭐가 되는 거죠? 이렇게 도는 거죠? 회전축이 어디 있는 거예요? 여기 있는 건가요? 이렇게 돌고 있는 거죠. 그런 축이. 근데 회전축을 갖다가 여기서 이렇게 수직을 세울 수도 있겠네요. 어떻게 돌아야 돼요? 이렇게 돌아야겠네요. 축 바꾸는 게 아주 흔하게 말씀드리는 일입니다.
But we do every process in this space, and in the space we have horizontal, we have vertical, and if you know it, again, it is our knowledge from physicists. You understand? We can immediately invent different category equipment. It is revolving movement also mixer, but here we have vertical location.
그럼 크레스 결국 있죠? 저는 회전축이 어떻게 된 게 수직으로 도는 거네요, 그렇죠? 자체가. 여러분은 세탁기 생각해보세요, 세탁기. 어떻게 돼요? 이런 세탁기도 있고, 이렇게 되는 것처럼 세탁기도 있네요.
It is very popular phenomenon in evolution of techniques, and you can remember blind for windows. Yeah? Blind for windows can have vertical category and have open closed with vertical axis, but you remember we can turn off axis and obtain new kind of blind. We must calculate it automatically because we know rules of evolution, and very fast see new design of products. And let me illustrate how we can recognize it in evolution of pencils, for example. And in evolution of pencil, we can consider typical physical contradiction, situation physical contradiction. As I mentioned, physical contradiction, special model for thinking about disadvantage. For example, you can consider pencil. If pencil open, it is good. You can immediately draw text. But if pencil open and you have it in your pack, pencil can be broken. Pencil can do contamination for your clothes. Immediately you must see physical contradiction. Working tool pencil must be open. Working tool pencil must be closed. Right? Two opposite requirements regarding the condition of
힘이 들어갈 때 그러니까 힘이 부서지지도 않고 또 오염시키지도 않잖아요. 그러니까 힘이 나와 있기도 하고 들어가기도 하잖아요. 그런 정도도 그렇게 많이 만들잖아요. 연기력을 나왔다 들어갔다.
An easy solution, you can use special cover. Oops, open, close.
공식을 갖다가
Oh, open, closed, it is forward movement. Right? Why not? And you can think, open, closed, but necessarily think about new design. Can I use impulse movement? Is it possible? Yes, it's possible also. And let me show for you. In this pencil, we have elastic thread, and we can open this pencil very fast. Jump, and we open. Jump, and we open. Impulse movement. After this, we must think, can we use pendulum movement? Oh yes, we can use pendulum movement. And you see pendulum movement open, pendulum movement close.
진정 운동이네, 그렇죠?
Open.
360 도는 게 아니니까 진정 운동이 열고 닫고 할 수 있는 거예요.
Again, pendulum movement open, pendulum movement close. But you know principle number 5, and you understand category of movement, you follow to principle number 5 also. And here you have only one pendulum movement, but why not? You can consider this pencil. Oh, in this pencil we have pendulum movement for holders also, but we have four pendulum movement together.
앞쪽에 세 개가 나눠져 있어요. 쪼개져 있어가지고 이렇게 열리고 하면서 나오고 닫히고.
And by the way, here pendulum movement have horizontal location, right? Here pendulum movement have parallel. Yeah? Again, turn of axis. Can we use revolving movement? Yes, we can use revolving movement for solving problem. Open and closed. Revolving movement. Closed, open, closed, open, closed, open, closed, open. And after this, we can think: can we use again revolving movement? And in this device, we have revolving movement also. You see wheel, and if I move this wheel, I will open system. If I will move wheel in opposite case, I will close the system. Can I use principle 13? You know today principle 13 together with this principle? Yes, of course. And it is big friend. And for example, I can have pendulum movement for open and close. Pendulum movement. Open, pendulum movement, close. But you remember principle 13, and right now you see locking system located in end part, but locking system can be located in front part. And in next solution you can see we use pendulum movement also, pendulum movement open, pendulum movement closed, but locking system located in front part. Again you calculate new realistic solution. It looks like as mathematics, but not strongly mathematics. It looks like as discrete mathematics. And it is really discrete mathematics. And via this principle we can calculate new kind of solutions.